All right.
Hello, Professor.
Hey, let's get started. I'll just start sharing my screen. Meanwhile, any questions so far that we had?
No, sir.
Okay, then let's see. Today is the last session, and it won't take a lot. We'll be just going through the solution. So and then the second half I can probably leave in case of anyone has any questions or anything, or you want to discuss any particular topic. Then let's use the remaining time for that. Okay, so let me present my screen. Okay, you can see my screen, right? Let's get started then. Okay, so in the last session, we kind of did a walkthrough of the problem statement, and we saw there minute differences, between what I have versus what you have. But the approach, the data, and whatever functions that we need to solve it remains the same. It probably just the variable names might change. So with that, let's get started into the problem solution overview. So we'll start with the market analysis. Uh, we'll go directly to market analysis. Okay, so we have the customer data, internet data, and churn data. These are the different types of data that was provided. So if you see here, we have employee data, internet data, there is the churn data, uh, and some customer data. So we have most of it, and then we also have the data dictionary that was shared with us. So pretty much everything is in place. Okay. Next, if initially you should basically do all of the data merge, create the tentacle data set, and find the total number of columns, and replace churn with yes or no wherever there is one and zero. Right. So let's see if this is the one. Yes, perfect. So for all of this caption project, you just need two libraries, pandas and numpy, mostly nothing else. And then you are doing a read underscore CSV of the CSV files, and this will be your location where the file is present. And then once you load it, it's always the best practice to see the top few records. I'm doing ahead to see, okay, how is the data. So typically you get the all of the records, and uh, you should see a depend variable at the column in the last column, which is the churn. And then how do you replace? So there are multiple ways to do that. So this is method one, and this is method two. So let's see method one. So method one, So you can do it with the help of a map function. So what does it do? It does a mapping of all the values that you have in the data to zeros and ones. So if you see churn dot map, yes is one, no is zero, right? So you are able to map the data. So I can simply say this and map, and that should give. Let me just simply connect. Just saying if the suggestions come. No, the suggestions are not coming. Yeah, okay, perfect. Okay. So if I do the map function, I'm getting the help. So here you can see it collects mapping subclasses or a series mapping correspondence. So you basically need a series with the mapping correspondence. And you can see here it's a series that you're passing, and this series you can do s dot map. So whenever for this particular series you can say whenever there's a cat, it's you make it kitten, dog to a puppy. So these mappings will get updated in the data set. So you can see here, and if you don't give a particular mapping, then it becomes not applicable, right? Like nan. So here rabbit is there, but we didn't shade the mapping of rabbit, so it is becoming none. So that's how the mapping function works. Now the second method is filtering for yes and then assigning it to one. So df of churn is whenever double equal to yes. So what does this give? This gives you a 0 1 vector, because you're basically checking is an element of churn is equal to yes, and whenever it is true it becomes true, whenever it doesn't map it will become false. And the true false vector you're passing through the data frame and then filtering only for the churn values. So the output of this will be a series of yes, and that series of yes you're saying assigning it to 1. In the same way, this particular statement gives you a series of no, and that you're assigning it to 0, right? So this is a very straightforward way of doing it. I'm pretty sure all of you might have used this method, but this is more easier method. Okay. Once you do that, you can do a df.info to see whether, okay, whatever operation you have done in the top is getting validated. So you can see all of the columns and how many non-null count is present and what is the type of it. So if you see churn is an int 64, it is not an object or a string or any kind of thing. It's an integer. So essentially the yes or no values were replaced with zeros and ones, and it has become an int type data type. And then let's go back to the question and then see. Okay. At this point, we want to focus our analysis only to the customers who are still with the company. So you have to say churn equal to no. You have to filter and then get a data set. So we are getting a sub data set df underscore one with df of churn double equal to 0. So these are the customers who are still with the organization, who have not left. And if you see only churn equal to 0 is what we can see in the sub data set that is getting filtered. Any questions so far? Okay, so 3 second rule. I don't see any questions. Let's proceed. Next, 2.1. Filter the data to keep only churn equal to 0. So that we have done. And then what is the number of rows remaining in the data frame after filtering the data? So you can simply do dimension of this df underscore 1, and that will give you the total rows. Next, check the average monthly charges for various contract types, and then what is the average overall monthly charge irrespective of the contract types. So we have to do a distribution by the contract type. So if you can see here, df underscore 1 dot group by contract. So that, and then if you put monthly charge, if you pass it and then do a dot mean, so by different levels of contract you are going to get the mean of monthly charge. So this is the syntax for that. So you can see the contract price month to month or 1 year or 2 year, and the average monthly charges for each of it is coming up here, right? So you are basically getting the averages computed as requested. And also they want what is the average overall. So you simply have to do a mean df underscore 1 of monthly charges dot mean. You don't need to do a group by. That will give you the overall monthly charge. Okay, next. What percentage of males and females have contract type as 1 year? So you need to filter out for this particular contract type and then do a group by males and females. Okay, let's see. So I here what we're doing is df underscore 1 of contract is double equal to 1 year. So this is essentially creating a true false vector wherever there is 1 year, and that I'm passing it with df underscore 1, and then I'm filtering only for gender. And then if I do dot value counts, so what it will do is it will give you a frequency by the filtered 1 year gender type. And then I'll basically getting the value counts, and then which is when I say normalize equal to true. What does normalize do? It essentially gives you percentages, and then into 100 just to get it in you know you are basically multiplying it, so it become percentage. So you can see this is the male percentage and this is the female percentage for the 1 year contract that you are keeping. Next, what are the average monthly charges for senior citizens and non-senior citizens? So though there are different questions, if you are able to solve the function for one, it is the same function, just the variable names will change, but the rest of the you can simply apply for all of the questions that are out there. So you here you can see you're just doing a group by senior citizen dot monthly charge dot mean. So for different levels of senior citizens, which is 0 or 1, you are getting the monthly charges mean. Any questions? Okay, no questions. Let's proceed. Which type of internet service is most popular among the customers? And what percentage of customers prefer this type of internet service? Okay. So if you see, you have to simply get the value counts by different levels of internet service. So you have DSL, fiber optics, and none. And DSL has the most. So basically, the customers prefer DSL type of internet service. So that is the most preferred internet option. Next, which method of payment is more preferred by the customers? What percentage of customers prefer this mode of payment? The same thing by payment method. Dot value counts, and then uh, you can get mailed check is this much, electronic check is this much, and so on and so forth, right? So the maximum people are doing a mailed check to the utilities company. Okay, so this is sorted. Next, check if the following services are preferred by the customer or not. Use bar plot to plot all the services, uh, and basically for each of these variables, like multiple lines or paperless billing, online security, online backup, device protection, streaming movies, and all of these, you basically need to create a bar chart. It's very simple. Df underscore one, whatever variable you want to do, dot value counts. So this will give you a vector, a frequency vector with different unique values. And this, when you say dot plot kind equal to bar, that basically whatever values, unique values you get it in the form of a bar chart. Very straightforward. So if you are able to do this, it is very simple to replicate it for the rest of the variables, right? Because the syntax, function, everything is going to be the same. It's just the way you change the variables and all of that. You can simply change the variable names, and rest all is um, going to be the same. For example, the next one they asked about is paperless billing, online security, online backup, blah, blah, blah. So you simply, it's the same code that you're using. You just copy it and then say change it to paperless billing, and then online security, and then online backup, device protection, tech support, streaming TV, streaming movies. That's it. So with this, you should be able to complete the entire question. And they're saying what is the sum of counts of multiple lines and paperless billing together input from the bar plot. So you will simply have to do a count of all of those unique values. That's it. Any questions before we go into churn? Any questions?
No, sir.
Okay, then let's proceed to churn. So we got the telecom data, and there's a data dictionary. Once the market research report is sent to the free shell, they are now interested in knowing about the various factors that are influencing churn in the market. They do want to understand why a customer is churning so that they can learn and then come up with different marketing campaigns to attract the potential customers. As part of the problem, decides to build a classification problem using the query so that it can be answered. You'll build a churn model using logistic regression that will help you find relationships between various factors and target churn variable. These are the different tasks that need to perform. One, data cleaning. So you do any kind of missing and outlier treatment as required in the data. Then data preparation and analysis. Drop the variables that are not going to be used in the classification model, like state, area code, phone number, customer service calls. And then what is the remaining number of variables left? Okay, let's go back here. Um, you load the data, clean it, and do all of it. And then here, I'm just loading the data, read underscore CSV, telecom dot CSV. And then these matplotlib and cbon are like for the visualizations that we have imported. And these are all the churn columns. You can do a count, how many you have. And then once we drop some of the variables, churn dot drop state, area code, phone number, and uh, some other column that we require. It's essential to mention whenever you use drop, what is the axis that you want, by what axis you want to drop. In place is equal to true. So what does this do is you need not assign the output of this to a new variable. It is going to replace it in the in place, within the same data set. It's gonna replace the data. So the dropped variables are gonna be dropped from the original data set. Next question. Replace yes with 1 and no with 0 for the following columns: international plan and voicemail plan. What is the number of yes entries in the column for international plan? So you have international plan and voicemail plan, and dot replace yes no with 1 comma 0. So yes is going to be replaced with 1, no is going to be replaced with 0. So for both, in place equal to 2. This is very straightforward. So this is similar to the map function and that we used. Instead of map, we are using now replace. So this is another third method of uh, you know replacing the variables. Remember we did dot map, and this is the third method of using this column. Okay. Okay, now once you do churn dot head, then you can see how many yes and many no are getting replaced with ones and zeros in the international plan here, this column. And then the voicemail plan also is replaced with zeros and ones. Next question. Create three new columns: total minutes, total calls, total charges, which is the sum of all of these three. And then you need what is sum of average values for all these three. So total minutes, total cost, total charges is nothing but each of the columns unique values and plus sum of that. And then you can take the sum and can compute the average. Straightforward. So this is like a simple addition of the column values that will give you the output that is being asked. Next, drop all the following columns: total day minutes, day calls, and know all of these, because it will create multicollinearity in the data, right? So whenever you create uh, a new variable out of these existing three variables, then when if you're using the new one, then we need to drop, because this is going to create a linear relationship of the dependent variable on these multiple different independent variables. So whenever there is a relationship between the independent variables, it can cause multicollinearity, and that's the reason we are dropping these individual variables from the data set. So we are simply doing churn dot drop, total day minutes, day calls, day charge, similarly for evening and night. So, and we are doing in place equal to true. Any questions?
No, sir.
Okay, then let's go to the next one. Split the data into X and Y, where X will have all the independent features, Y will have the dependent features. So this is very simple. In X, you're gonna, for the way data set, you're gonna drop the dependent variable, and then Y you will assign that dependent variable, right? So essentially you should do this reverse, because once you drop, you, oh, it doesn't matter, because we are not doing in place equal to true, right? So we are assigning it to X. So this should be fine. Next, check the imbalance percentage. So you simply have to do y dot value counts into normalize equal to 2 and 200. That will give you like 15% of the data has ones or the churn, which is a pretty balanced data set. So this is good. Randomly split the data into train, test, and use the following parameter. Train size is zero point 0.7, test size is zero point 0.3, random state is 100. What
Sir,
is the
I have a
number of?
doubt here.
Yes.
Sir, here when we were checking the imbalance percentage, we saw that for no, I think it was 85%, and for yes, it was 15%. So if that
Mhm.
is the case, then how, I mean, I suppose you said that the data is balanced. So how exactly it is balanced if it is not 100%?
Got it. So typically for the model to be able to perform well, at least 20% of the values of the level should be present in the data. So here it's like 15%, right? Like with the values of one is.
Mm.
So that is still okay. But if the unique value, if the percentage drops below 10%, then it's like completely imbalanced data set. You will have to think of something else. And there could be cases where there is less than 1%. For example, credit card fraud. Out of thousands of transactions, somewhere one transaction there'll be a fraud. So in that case, that is called as rare event data. So it's a very rare event, and you have to do certain methodologies like rare event modeling. So whenever once 1% or less than 1% cases have some kind of a fraud, and then you need to detect those frauds in the training data set.
Okay, okay.
Clear?
So basically, theoretically, it is imbalanced, but practically, it is still balanced.
Correct. Correct.
Okay,
So for modeling purpose, you can still do it, because why we are doing this balance percentage or imbalance percentage check is to see whether whatever modeling we are doing, uh, the output of that should be reliable. So the models cannot perform well if the balance percentage is less than a threshold, like 10%. Then
okay, okay, sir.
you cannot even build. Okay,
Okay,
cool.
okay. I asked this question, sir, because actually we were not aware about this particular thumb rule of 20%. So, like,
Mm. So it's very important, even for once you build the model, if you want to calculate the probability, right? So what will be the probability, the cutoff that you will choose? So the output of the logistic model is a probability, correct? The y you get an equation y equal to mx da 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 the some equation, and then once you build the model, what is the eventual output? You get probabilities. That is the output of the logistic model, and then you do a cutoff. How much should I put a cutoff so that I classify it as 0 or 1? So let me see if I'm able to showcase that here. Okay, so if you see here, I'm fitting a model, log model on X train, Y train, right? And the eventual output, Y pred, is this zeros and ones? Y pred? No, it will be a probability value between 0 to 1. And then you need to
right.
basically say uh, whether I should put it in 1 or I should put it in a 0. So and that you do decide based on probability cutoff. How will you determine the probability cutoff? Should you use zero point 0.5? No, because zero point 0.5 is when that probability cutoff will depend on your balance of your data set. If it is 50 zeros and 50 ones, then typically the probability is 50% probability cutoff. But if it is now 15%, then your probability cutoff should be in that range. And it will be between zero point 0.1 to zero point 0.3, somewhere like that. It won't be exactly 0.15 like the distributions of zeros and ones. So you typically determine the probability cutoff of a logistic model with a it's called chart, or you have sensitivity specificity chart. Let me show you the chart. How does it look? Okay, let me open this link. So this is a sensitivity specificity chart. Okay, so one second. Let me show this is in general for logistic regression. Let's do that. Okay, so this is how the chart looks like. And then if you see the probability cutoff here, it's coming as 0.36. It's not zero point 0.5. So every model will have a different probability cutoff. And that is basically you have a sensitivity and the specificity curves. So these two curves will meet at a point, and that becomes your probability cutoff. And you use that probability cutoff to classify whether it's a 0 or 1. Your Y-pred, whatever you get, you need to classify whether if it is less than this, then it's 0, then greater than this, then it is 1. So so that's how you determine. Okay. Any other questions? Anyone? Okay. Then let's proceed. We were doing the imbalance percentage and all of that, right? So where were we? Mm-mm-mm. Yeah. We split the data set into train, test, and all of that. After we do the imbalance percentage here, and then we are now building the model, importing the min max scalar, and then scalar dot fit transform on x train and x text, and you basically have that split. And then you're doing the log reg, the logistic regression model with how many iterations, and you're saying class weights as balanced. So this is where, so different, there are different types of logistic regressions that you can do. You can do a equal balanced class weights, or you can give weightage to a particular class in the model. So that's called weighted uh, uh, method, but typically you use the balanced for our use case. And then you're fitting the log reg model, and then you're getting the Ypred. So Ypred is going to be probability values that you're going to get. Next. Next, we are basically getting the accuracy score and recall score. So Y test and Y-pred, if you pass through this, you will get the accuracy, where how well did we predict. So here, if you see, we are not putting any cutoff, right? So Y-pred is a value between 0 to 1. Y-test is either 0 or 1. So this is typically taking zero point 0.5 as the cutoff by default, which is a wrong method. You should ideally put a cutoff of zero point 0.2 or something like that, or you need to build this sensitivity specificity chart even before you can arrive at this. But all that is not explained because that is little advanced, and I'm pretty sure it was not covered in any of your concepts. Okay, now let's proceed. Mm, Scale the data using min max scalar, fit a logistic regression, class weight is balanced. Then they're asking for R square, train the model, check the sensitivity and accuracy of the model on the test data. So we have that, and we got the accuracy score and the recall score. And then this is more of a feature importance output. So for different features that you have, what are the different coefficients for each of the features? You're essentially getting an output of that. Any questions?
No, sir.
Okay. So then let's do a quick 10 minutes break and then we will continue the next two questions. We just have customer segmentation and then the HR analytics. So that shouldn't take time. So we'll take very small break, like few 10 minutes from now. Okay. See you guys. Okay, let's continue. Subrat, you're here. Sachin, can we
Yes,
continue?
sir.
Okay,
Yes, sir.
perfect. You're able to hear me, right?
Right.
Okay, perfect. Good. Okay. Customer segmentation. Now, the free sell team is aware of the market and the different factors influencing the customers to churn. Free sell has decided to do a marketing campaign, and before they actually do, they're willing to understand the possible customer segments that they can target. In this module, we'll try to segment the customers based on different features and later try to profile the segments which they'll be presenting to the free cell team. To perform the k-means clustering, we'll use all the columns. We will not be using all the columns, right? Because there'll be certain useless columns which will not give information about the customer segment. So we'll drop them. And based on the number of calls made by the customer and so on and so forth. Data preparation. Filter the data and keep only the columns: total day calls, total night calls, total evening calls, and total international calls. The rest of the columns are not helpful for creating those customer segments. And then you need to perform, max scaling, and then you perform the k-means. Okay, let's start with the coding part. So for the data set that you have churned, total day calls, night calls, evening calls, international calls, you basically only select a subset of the fields and then you do a head that will give you the top few records. And then we are using the min-max scaler, which comes from scalar pre-processing. Import min-max scaler. So you get the min-max scaler, and then you basically say scalar dot fit transform of the cluster. So that is going to give you the transformation on the data. And once you do that, we are going to import k-means, import silhouette score, and matplotlib and reborn for any plots. Next, for this is similar to the code that we did a walkthrough previously. We need to compute a standard error, SSE. So I'm initiating a null, and then for k is equal to 2 to 10 or 2 to 9 in that range, you run multiple k-means. We are doing k-means when n equal to k dot fit of cluster scale, and we are computing the SSE. We are just appending for each value of k what is the silhouette score. You basically get the value of the cluster and the k-means label that you have. So the cluster, the data frame, and the predicted labels of the clusters, you pass it to the silhouette score function, and then you basically going to get k and the silhouette score, and then you're plotting it. So you can see that at one point at 3 you get the maximum uh, high silhouette score, and then you kind of use that as the optimal value of k from the silhouette score. And then for the elbow curve, you compute something called SSD. So SSD also similar from 1 to 10. You basically run the k-means and you say model underscore class dot fit. And then there is something called inertia. Inertia is what will give you the standard deviation SSD, and you for every value of k. So once you plot it, plot dot plot of SSD, then you basically see, if you draw a tangent again somewhere between 2 and 3, so probably 3 is the optimum value of k that you will need to use. And then for that value of k, you basically run the cluster k-means, and then you fit it on the data, and you get the cluster labels added. Okay, so that's how we have computed, and then you and then you can get the output. Okay, let's see k-means. Okay, filter the data, keep only these, perform in max, check the silhouette score, check the elbow curve, run k-means to get the final value of k. We have done all of this, and plot to visualize the clusters. So we are using SNS to scatter plot X, Y, and then you put few labels, which is the cluster labels, and you will be going to getting the cluster plot. The last question in K-means is profiling. Check the average of various features to understand the properties of different groups. And then what is the highest cluster mean value in each of those values? So for each of the variables, a total day call, night calls, evening calls, international calls, you basically get all of the averages mean for different labels, and wherever is the highest, you basically say, okay, you come up with insight, this cluster has more day calls and so on and so forth. Cool. Any questions?
No, sir.
Okay. Then let's go to HR analytics, the last one. So in the people analytics or the HR analytics, they basically have done a lot of context, and they basically want to do certain filters, and you need to only consider attrition equal to no, and then you need to put certain constraint, like company wants to know of the characteristics of the current people who are associated for more than 5 years, job satisfaction less than 3, work-life balance is less than or equal to 3, and have not been promoted for the last 3 years. And you filter only for this and start answering. So first you need to create a filtered data set. So let's see. Yeah, import pandas, load the data set, and then you are basically filtering one single sentence code to which explains the filters that we have added from here, right? Like what all of these, whatever is mentioned here, you convert into one single statement. Yes, as at company greater than 5, last promotion, job satisfaction, work-life balance, attrition is no. And you get the filtered data set M. And now we have to do analysis in that sub filtered data set for each of the questions. For R&D, now from the R&D department, they want to send one employee with current job role this, and then they have to, as it's a scientist, they need to be performance rating, job satisfaction, education field, not in medical. And then you need to get from all those filtered employees what is the mean. So same. So we did by department. There's R&D, sales, and HR. So now for within R&D, you filter and you get R&D, and similarly you get sales and HR. And then in the R&D, you want job role to be research scientist. Monthly income is less than equal to 7,000. Performance rating is greater than equal to 3. Stock option level should be 0. And educational field should not be medicine. So that's why we put np.logical not. So that is another way that you can do a logical operation on the data. And whenever we say education is not equal to medicines, that way you can filter out and get all of the R&D folks. And similarly for sales, uh, performance rating, job satisfaction, business travel is non-travel, and blah blah blah. So similarly for sales, job role is sales executive, performance rating and business travel is equal to non-travel. So you get the filtered data sets, and then you basically get number of the sales employee that fulfill total count, mean of the monthly income, and so on and so forth, that you can get once you get the filtered data set. And then the final question was on concatenate sales and research teams and filter the data based on education level being 3 or more. And what is the total number of rows? So you now have these two, um, and you are concatenating the R&D and D and the sales to get a data frame, and then you're filtering df of education where x is greater than or equal to 3. So wherever the education is greater than 3, you're filtering, and then you get the final data set. and then you do the shape, you get how many rows and columns you have. So that's pretty much it. Any last questions on the overall caption project?
Sir,
Pretty much.
here,
Yes.
sir, I had a question. So
Mhm.
here in this, we just needed to filter the records based on the conditions given. That's it.
Correct. Correct.
Okay. Oh,
So there is a library that I explained also called SQL DF. So if people are comfortable with SQL DF, I would recommend using this library. So this is like you write a query and you simply say SQL DF dot run of query. So it's like on the pandas data frame you can write queries. This is much more simpler, and I think people who are comfortable with SQL, they can use this method.
okay.
Any other questions?
No, sir.
Okay, then remaining time I'll be here in case if there's any questions or anything. Feel free to jump in and ask those questions. And thank you so much. You have been an amazing cohort. No questions that I've gotten much. So anytime you need anything in terms of the course or career, anything, happy to reach out to me on LinkedIn or anywhere, and would be able to assist you guys. And wishing you all the best in the course and as well as in your careers. Yeah, I'm just around for another half an hour in case you want to ask any questions. Cool.
Thank you, sir. Thank you so much.
Thank you.